Hello everyone, this is my demonstration of a Weebot's robot that can plan a path in a known world. So let me first bring this up. So in this, basically, I have a goal pose of cell 1. This is where it wants to end up, and it has a goal direction. So it wants to face north once it gets there. So to begin, we put a 2 right here in this spot to signify that that is the goal pose. So the way that I'm going to go about solving this is using the wave front path planner. So there it is. So basically the way that the wave front path planning algorithm works is you put a 2 in your world's basically cell, and then you start incrementing values of available paths back towards your starting position, which is where the robot is. So from this scenario, I'll go through it step by step. So since this is the end cell at cell 1, I'm going to put a 3 here since it's the only available position. You can see that was the only spot left. So I'll put a 3 there. Here I'll put a 4 since that's the next spot, and since 2 is already filled there. So there's a 4 here, and now there's 2 different options. I can go right or I can go down. So I'll put a 5 in both of those. And then from both of these 5s, they can both go down, so I'll put a 6 there and a 6 there. And then for this 6, it has a left move, so we can put a 7 there. And this 6, it has a downwards move, so we can put a 7 there also. And this 7 has an upwards move, so we'll put an 8 there. And this 7 right here has a downwards move, so we'll put an 8 there. So that's all been done, and this portion of the algorithm has been completed. So basically, we mapped a value direction. You can see this incrementing all the way from the end pose all the way to the goal pose to the starting pose where the robot is. So the next portion of this algorithm is to plan our path. So basically, we're going to start at we start at our starting cell, and we know that its value is 8. So we're going to look for a value of 7 in a cell that's around it. So there's not a value here, and it wasn't 7 anyway. This is represented as a 0. So we look here at this one, and we see that it has a 7, and that's what we're looking for. So we need to go and ask ourselves, what move do we need to do that? We can see that this spot above us is a 7, so we'll use a forward. And we go and do that same thing. Since now we're here, we're in 7, we're looking for 6. There's only one move that we can make. So we go and look up at 6, or up here, and that's where 6 is. So we know that we need to make another forward. Do the same thing, we need another forward, and then repeat for left, left, and then we're here with our third left at the goalpost. So I'm going to go and add those onto a deque called plan. So I'll append those moves. You see, starting at index 15 to cell 16, we go and move up 1. So we used forward, and the value there was 8. So we can see from 8, we used a forward to go up to 7. And then this is cell 16, the index is 11. So it has a value of 7, and we needed another forward to go up here to 6. And we just keep doing that. And then we go up here, 6 to 5. And then we know that we need to make 3 lefts. So I'll skip to those, left, left, left. And those are the 6 moves needed to go from here at 8 all the way to 2. So the last step is to execute this plan, which is all stored on a deque. So we are going to pop the left side of the deque. So usually popping involves the top part of it. So we're going to pop the bottom part of it. Show that right here. Pop left to get the move. The first index was the actual motion, and then from those motions we can see that how we're supposed to turn ourselves before we go and move to the next cell. So I'll show that. It's going to move forward 3 times and then turn left and go that way. So it's going and marking all of those cells with X's because it's visited them. It should face left. And then it's going to face north again to make sure that it faces left correctly. It's going to go here, face north again. And since our goal direction was north and the goal cell was supposed to be 1, it stops right there and it prints out goal, and we planned out our path before we moved and we did it all in 25 seconds. And since it reached its goal with the direction it wanted, it printed it out. So that is a demonstration of a wavefront path planner, and it worked correctly. So thank you for watching.